This is the first video for Unit 7, and we are starting, this video is going to start by talking about some new trig identities that we learned, and we learned the sum difference identities for sine, cosine, and tangent, as well as double angle identities. And this video is not going to be deriving those identities. You can go back to your notes from class for that. But it is more about the applications. And these identities, like many that we've talked about already, are important for calculus and useful in certain applications. So let's just, though, talk about the problems we might encounter with them. So first, when talking about the sum and difference identities, well, knowing these has now helped us to solve or evaluate and finding without using a calculator, so find the exact value of some more angles. So for example, we could do something like now cosine of 5 pi over 12. Before, this isn't one of our, it's not a 30-60, it's not one of our special angles where we could use our 30-60-90 triangle, 45-45-90 triangle, but is there something that could we use what adds up to 5 pi over 12 and then apply the sum or difference formula in order to then find the exact value. So in doing this, particularly if it's in radians, I think of, okay, if with a denominator of 12, let me think of some things that add up to 5 on the top, or 5 pi. So 2 pi over 12 plus 3 pi over 12. And the nice thing here is, well, 2 pi over 12 is pi over 6, and that's one of our special angles, and 3 pi over 12 is pi over 4. So sometimes you may have to experiment a little bit until you get something that ends up being an angle you will know the trig functions of. Okay, so I have the cosine of this sum, and hopefully by now you've learned that you cannot distribute cosine through addition, much like when we talked about logs. You cannot distribute a log across addition here, because cosine stands for a function, so it's not a number itself or a variable itself. Okay, so the formula is for cosine of a sum is cosine pi over 6 times cosine pi over 4 minus sine pi over 6 sine pi over 4. And then it's just a matter of what we've done in the past is evaluating the cosine and sine of these various angles. So cosine of pi over 6 will be root 3 over 2. Cosine of pi over 4 will be root 2 over 2 minus sine of pi over 6 is a half times root 2 over 2. And this is just going to become root 6 minus root 2 over 4. So that's one example of how you might use in this case, it was the cosine of a sum. And so what about, let's think of something else. What about if instead I gave you a problem like the following? So maybe the directions are simplify. And maybe I'll even take it a step further and say simplify, find exact value. And you could see something like this. You could see cosine, let's make something up here, 7 pi over 9 cosine 2 pi over 9 minus sine 7 pi over 9 cosine 2 pi over 9. Oh, it's not cosine, sine. Well, this is a matter of, well, I don't know. I can't evaluate each of these because 7 pi over 9 isn't an angle that I know the cosine of, but I do see that this looks very much like one of our formulas. So it's recognizing that. And then what is that formula? Well, this is the formula it's actually the formula we just used above, cosine of a sum. So this would be equal to cosine of 7 pi over 9 plus 2 pi over 9. Which works out to being cosine of 9 pi over 9, or cosine of pi, which you should know to be -1. So something that may look a little bit complicated, we actually can make simpler by doing, by recognizing that that involves one of our new identities. All right, how about something a little bit different? And this is still sticking with these sum difference identities. Let me open up a new sheet. So what if I told you, let's see, maybe, let's make something up here. Maybe I say sine of A equals -2/3, and A is in quadrant 3. And then I tell you that, actually not sine, I tell you that cosine of B equals 4/5, and B is in quadrant 4. So you know that, and then I say find sine of A minus B, and so that's part A, find sine of A minus B, and then part B will say find tangent of A minus B, and part C, what quadrant is A minus B in? Is angle A minus B in? Okay, so am I going to be able to find angle A and angle B? No, but I can use the information that I gave you, which is the ratio and what quadrant that angle's in, because that is important. So let's draw what we've got here. Let's draw where A is. So I've got A is in quadrant 3, and I've got the sine is -2/3, which means the x value is going to be also negative since it's in quadrant 3, so -√5, I believe, 9 minus 4, yes. So this is A. And then let's draw B, which is in quadrant 4, and cosine of B is 4/5, so the y value will be -3, just the Pythagorean relationship there. Okay, so let's do part A. So sine A minus B is sine A cosine B minus sine B cosine A. All right, so let's look, we're going to use our triangles to figure this out. So sine A, if I go to this, the red triangle here, sine A is -2/3. Cosine B is 4/5. Minus sine B is -3/5. And cosine A is -√5/3. All right, so let's see what we've got here. We've got denominator both is 15, so I've got not -12, excuse me. We've got -8, and then -3√5/15. So one thing, because I'm gonna need, well, actually, no, I'm gonna leave it like that for now. All right, I'll get back to what I was gonna say when I answer part C. All right, so part A, that is sine of A minus B in exact form. Okay, let's do part B here. B tan A minus B is tan A minus tan B over 1 minus tan A tan B. 1 plus, sorry, tan B. Minus is on the top, plus is on the bottom. Okay. And this is going to be not pretty, but you know what? We're not going to simplify it too much. So tangent of A is going to be -2 over -√5, so 2 over √5, minus tangent of B is going to be -3/4 divided by 1 plus tangent A, and then times -3/4. Okay, so not exactly pretty. So I've got 2, maybe I'm going to do it like this. I'm going to say 2√5/5 plus 3/4. And then I'm going to divide that by, I'm going to put the root 5 on top. So 1 plus -6 root 5 over 5 times 4 is 20. So I just rationalized the 2 root 5. What I did there before I multiplied in my head is I just made this 2 root 5 over 5. So then when I multiplied it by -3, it was -6 root 5. So over 20. And the reason I did that is I just want to clean it up a little bit. So if I multiply the numerator and the denominator by 20, I can just get rid of that complex fraction. I'm not going to rationalize the final, but I just want to make it a little bit cleaner. So what do we get here? We get 8 root 5 plus 15 over 20 minus 6 root 5. Okay, all right, I'm going to leave it at that. Like I said, I'm not going to rationalize that. Okay, part C. What quadrant is A minus B in? Well, we're going to use the previous information to tell us that. So I'm looking at the answer we had for part A. The sign, the ratio when I take the sign of A minus B is going to be negative. Okay, so that limits us to quadrants 3 or 4. Now we have this other piece of information, tangent. So when I look at tangent, the numerator's positive. The question is, what about the denominator? So 20 minus 6 root 5. Well, root 5 is between 2 and 3. So that, and when I multiply that by 6, I am not going to take over 20 and be negative. So 6 times 2 in sum is not going to, 6 times 2 is 12, 6 times 3 is 18, so it's between 12 and 18, so it's not going to make the denominator negative, so this is positive. So what quadrant am I in? If sine is negative and tangent is positive, I am in quadrant 3. So that was a problem that we encountered. All right, let's then switch gears a little bit. Actually, maybe in video 2, I'm going to switch gears a little bit and then add into this the double angle and some problems there.